Hi, good morning. Today's video we are going to evaluate this integral natural log of tangent x dx from 0 to pi over 2. Previously we evaluated the integral natural log of tangent x plus 1 dx, but the bound was from 0 pi over 2. Let's see today this one. This one we always go through substitution when you see like this kind of integrals. So there is a connection between tangent x, sine x and cosine x. Let's put this one on this form from 0 pi over 2 natural log of sine x over cosine x dx. It gives us 0 pi over 2 natural log of sine x minus integral from 0 pi over 2 natural log of cosine x dx. Okay, let's call it I1, the first term integral. Let's call I2 the second term integral. Okay, we are going to work on I1. We are going to see the value how looks like, and then what's the connection between first integral and second integral. Then we decide what to do. Okay, let's work on the first one, I1. We have I1 equal 0 pi over 2 natural log sine x dx, right? Okay, let's do the substitution here. Let's put x equal pi over 2 minus theta. Let's do the differentiation here. Dx equal minus d theta. Let's do the bounds. If x equals 0 and theta equal pi over 2. If x equal pi over 2, the theta equal 0, right? Let's log in here into our integral. Become the lower bound become pi over 2, the upper bound becomes 0. Natural log of sine x, we're gonna log in x by this one, pi over 2 minus theta minus d theta. Okay, we are just changing the variables from x to theta. Okay, this one in the same time, this one are going to change the bounds sign from the upper bound to the lower bound, switch them. Okay, when you switch the bounds, it come up with the negative sign. Okay, also negative sign with a negative sign, it gives you positive sign. So from 0 pi over 2 natural log of, what is this sine pi over 2 minus theta? Is a cosine theta. Is a natural log of cosine theta d theta. We are observing something here. This one is this one. Look. Okay. So I1 equal I2, right? So I1 minus I2. Yes. This one equal this one. What does this mean? We are going to replace this one, our integral, into this one here. What's it give us? Let's put I equal 0 pi over 2 natural log of sine x dx, which is this one, minus 0 pi over 2 natural log of cosine x dx. This one, let's change it by this one, because we found out I1 equal this one. This means 0 pi over 2 natural log of sine x cosine x dx minus 0 pi over 2 natural log of cosine x dx equals 0, right? So that I equals 0. Okay, thank you for watching. I see you in next video.